Hello everyone and welcome back. This is the first time in a while that I've uploaded a video, and that's mainly because I didn't really have the time to prepare anything that I felt would be interesting enough. And finally, with the AMC10 and 12 approaching, there will be this video for the AMC10 and another one coming up with a mock AMC10 and 12 paper attached in the description, which you can also try out on your own. So to be clear, this video will go through all the problems as well. You will be able to find the answers here and the full solutions here. So if you would like to give it a try, you can hang around for the next 3 or 4 minutes while I talk a little bit about the AMC10 format, a few tips and strategies on time management, and on the contest format if this is completely new to you, as well as a few score cutoffs based on recent years. Now, after I've gone through all of these, feel free to pause the video, shut it down, try the paper on your own, and come back here even if it's a day later or even if it's just 2 days before the AMC proper. Right, the AMC10 should be in 2 sittings. The closer one's slightly over a week from now, and the further one's about 2 weeks from now. Okay, so first things first, what you see on the screen is going to be the same set of rules as the actual AMC, except maybe not printed in Times New Roman. The AMC10 format and the AMC12 format are the same. It is 25 questions, 5 multiple choices, and 6 points for correct answer, 1.5 points for a blank, and no points for incorrect answers. Now, this is to say that if you got a perfect score, this would be 150 points, and if you chose to leave everything blank, you would get 37.5, which is a fair bit away. Having said that, 1.5 marks for blanks means that if you were to guess randomly, 6 over 5 is 1.2, and 1.2 is less than 1.5. So if you were to guess randomly, you might as well just save yourself the time of clicking and guessing and just leave it blank. Unless you have managed to eliminate a couple of options by saying that the answer must be odd, the answer must be even, the answer cannot be too small, the answer cannot be too big, then by all means, guessing is now a good strategy if you can reduce it to 3 or fewer options. 4 options is up to your preference. Now, in terms of some statistics, what sort of score should we be targeting? Now, that matters especially if you are a bit new to the AMC and you're not quite sure what you should be doing. Should I try to solve everything? Should I try to solve 10 questions, 20 questions? Should I guess? What's a good score? And so on. Now, a very quick introduction with apologies to my American friends. For those of you who do not stay in the United States, you will take either the AMC10 or the AMC12 or both, and they are going to be qualifiers for the AIME, the American Invitational Math Examination. The AIME, combined with the AMC10, leads to the USA Junior Math Olympiad, and the AMC12 combined with the AIME gives a composite that qualifies you for the USA Math Olympiad. And when I say you, if you are American, then of course this entire track leads to the US Math Olympiad program, the IMO training team and preparation teams. If you live outside the US, you are only allowed to take the AMCs and the AIME. So the AIME is kind of the final step that you are allowed to take if you are an international participant. So with that, of course, qualifying for the AIME could be one of your main targets or priorities. And for the AMC10, your target is going to be, well, dependent on the difficulty. But the cutoff would be somewhere in the proximity of 100. Now, last year, or the most recent one rather, the 2021 fall AIME cutoff was 96 for both the A and B. The 2021 spring had a little bit of a higher cutoff. It was 103.5/102 for A and B. And if you go back a year further to 2020, it was also exactly the same pair of cutoffs. So this could be a gauge for you for what sort of target you would want. And you realize that's actually not that much in a out of 150 perspective. Because if you did, let's say, 15 questions and 10 blank, you would already be sitting pretty with 105. That assumes, of course, that you get 15 correct answers and 10 blanks. That would be enough to get in for all of the most recent sets of the AMC10. But the moment you make one mistake, you drop to 99. If you make another mistake, you drop to 93, and 93 would not have been enough for anything. So you would like to be able to have at least 16 or 17 questions if you want to be very assured that after a couple of silly mistakes, you still have enough to make it into the AIME. There are also two other awards: Distinction, which is the top 5%, and the Distinguished Honor Roll, fancy sounding, normally abbreviated as DHR, that's the top 1%. Approximately, if you are trying to be getting a distinction, that is not very far off from the AIME cutoff. Maybe it's going to be a little bit higher. Right? So I would say that it is slightly higher, slightly meaning maybe 5 to 10 points more. If we are looking for the DHR, that could be quite a bit higher. So that could be around 120 and maybe a little more. Now, having said that, we realize that I just mentioned you should be trying to get 16 or 17 questions to assure yourself of the AIME cutoff. Now, getting 120 requires you to get like 19 questions correct with 4 blanks, let's say. And oddly enough, you realize that's not that far away, right? Targeting 16 or 17 questions or 19 questions is not really a world of difference. Which is why, in practice, we don't need to have cutoff scores in mind when we're taking the AMC problems. We just do as fast as we can with sufficient care and accuracy. That's a slight contradiction, but go at a pace where you know you won't make too many silly mistakes. Right, so that's a pretty long preamble of about 7 over minutes. And so this is a final warning. If you like to try the paper on your own, pause the video now and come back later. If you're still here in about 10 seconds, I'm about to start going through the problems. Alright, so here we go. Now, for the AMC10 and the AMC12, whether you are targeting 15 questions, 20 questions, or anything in between, unless you are just doing this for fun as your first experience, if you have any of those as your targets, you should be able to solve almost all, if not all, the first 10 questions. And you would like to be able to do that, hopefully, in 30 minutes, thereabouts. Because if you take more than 30 minutes, like let's say 45 minutes to solve the first 10 questions, it is very unlikely you would even get to properly attempt 5 or 6 more questions, because the ones behind are going to be appreciably more difficult. So don't be too lulled into a false sense of complacency by the first few easier questions. Just bear in mind, the difficulty will go up, and sometimes go up very sharply towards the middle of the paper. So let's get straight into it. Question 1 is the classic AMC computation question. This is -1 plus 2 minus 3, which is -2. I like to always check my answers for these twice, just because they only take another 10 seconds to check anyway. So this is actually -2, so we can look at the second problem. Sally purchased 1 ruler, 2 pens, and 3 pencils from a bookstore for $3.21. The next day, the bookstore had a 20% discount, and Danny purchased 5 rulers, 10 pens, and 15 pencils. How much did Danny pay for his items? Well, we don't have enough information to find out how much the ruler, pen, or pencil would individually cost. But we do have enough information to just jump straight from this block to this block, since the ratio is still 1:2:3. So we can go $3.21 multiplied by 5 to get the full price, and 20% off is 1/5 off, means that you are paying 4/5 of that at your discounted price. So basically, you are multiplying by 4. So 321 times 4 is 1284. Now notice that I didn't multiply by 5 and then after that minus off a 20%. We are usually trying to do things as efficiently as possible. I said 30 minutes and I'm going to try to do it in this video in about 25 if I can. So we have to be efficient and also reduce the chance of making a silly mistake. Question 3. 7 numbers are written in a row. The average of the two leftmost numbers is 10. The average of the two rightmost numbers is 20. And the sum of all 7 numbers is 30. So there are 3 more numbers in the middle and we are asked to find the average. Right, so there are 2 numbers here, 3 numbers here, and 2 numbers here. Now, we can transition from the average to the sum. Just be very careful when you're reading the question and solving to know average, average, sum, average. Don't forget what we're supposed to find. So the sum will be 2 times 10, which is 20. The sum of the last two will be 2 times 20, which is 40. And so therefore the sum of these 3 is 30 minus 20 minus 40, which is negative 30. And so my answer is not negative 30, it is negative 30 divided by 3, which is negative 10. Question 4. Eldon used a geometry app to construct 5 regular polygons with 1001, 1002, 1003, 1004, and 1005 sides. What is the sum of the measures of all 5015 interior angles in degrees? Well, clearly, this is not something that we can draw, nor is it something that we need to draw. Since we are being asked for the sum of angles, all we need to do is get the sum of angles in each of the regular polygons. And the formula you would like to use is that for an n-sided polygon that does not intersect itself, the angle sum is n minus 2 times 180 degrees. Basically, the reason is that we can chop it up into n minus 2 triangles. So a pentagon would be 3 triangles, a hexagon could be split into 4 triangles. And each triangle contributes 180 degrees. So therefore, the sum of all these would be just adding each of them 1 by 1, and that would be 999 times 180, 1000 times 180, until 1003. Sorry, my degree sign's in the wrong place. Now, I don't want to multiply each of them 1 by 1 because 180 is a common factor. And I still don't want to add this and multiply just yet. I would say that for these ones, the average is 1001 and there are 5 of them. So that would be 1001 times 900, and that's the easiest thing to calculate ever. 900,000 and 900. So 900, 900, which is option C. Question 5. This is a sequence where you are, having to find out what's going on in the dot dot dot. Whenever you see dot dot dot, it means there's a pattern, and you need to know what the pattern is before we can actually calculate the result of the pattern. Now, the first part of the pattern is pretty obvious. The difference between our consecutive numbers is 3 each time, all the way to the end where you reach 1111. The other part of the pattern is that you are alternating between plus and minus for this entire thing. So what I need to do is to find a good strategy now that I know the pattern. And my strategy would be to just group them together into pairs, maybe something like this. Now, I always prefer positive to negative numbers, so I'm going to group them like this so that each group of them is just going to be 3. Except for the additional 1 down there. Don't forget about our additional 1. So the question left is, how many pairs do I actually have? And to find out how many pairs, I need to know how many numbers. To find out how many numbers, I take the last one minus the first one, divided by the common difference, and I plus 1. I plus 1, so 371 is the result. Now, 371, if I were to divide this by 2, I get 185 remainder 1, meaning I have 185 pairs and 1 extra 1. So my answer is 185 times 3 plus 1, which is 556. And notice the 555 sneaking up there to trick you if you did not remember our plus 1. Question 6. Suppose that x is a real number such that 4 to the x plus 4 to the x plus 4 to the x plus 4 to the x equals to 32 to the power of x. What is the value of x? We have got 4 copies of 4 to the x, and that means that I can write it as 4 times 4 to the x, and then bring that in. This is 4 to the 1, so 4 to the x plus 1 is 32 to the power of x. Now realize that here both of these are powers of 2, so I can write this as 2 squared and 2 to the power of 5, and so 2x plus 1 equals to 5x. Right? Our indices rules allow us to just say that our exponents get multiplied, 2 times x plus 1 and 5 times x. So 2x plus 2 equals to 5x, and 3x equals to 2, x equals to 2/3. Question 7. How many square numbers between 222 and 2022 inclusive have a last digit of 4? So I don't want to list out all the square numbers because I know most of them do not actually have a last digit of 4. And the key for last digit is that you only need to focus on multiplying the last digit. So I can just look at 0 to 9. I know that it must have come from an even square number. So I can just check 2 times 2 is 4, so that could work. 4 times 4 is 16, that would not work. 6 times 6 is 36, that would not work. And 8 times 8 is 64, that would work. In other words, I'm only looking for numbers ending in 2 or 8, which I square. Now I know that 222 is more than 100, so basically it is more than 10 times 10. So I only need to check at the boundary 12 squared, which is too small. So the next one would be 18. And 18 squared is most certainly big enough. It is 324. So this works. And I expect that all of these would work until I burst the limit of 2022, which 50 times 50 is already going to exceed. 40 times 40 is not going to exceed, so I only need to check 42 and 48. 42 is small enough, and 48 is large enough. Sorry, 42 is small enough, and 48 gives you something that is too large. Not large enough, too large. So the ones in the middle work, which means there are 6 in the correct range. Now, if you knew that 45 squared was 2025, that would have been really helpful, because it means that 48 squared is obviously too big and 42 squared is obviously okay, and you would have saved yourself a little bit of time in calculations. It's always good to know a square number that is close to your year, and unless some of you are really young, or, well, I think even if you were really young, you would still be living with 2025 as the closest square number for a really, really, really long time. So good to know 45 squared is 2025. Question 8. Two fair 12-sided dice containing each of the numbers 1 to 12 are rolled. What is the probability that the product of the two numbers is a multiple of 16? Here we are multiplying. And when we are multiplying, it means that you are kind of trying to see, have I gathered enough factors from both of my dice? Now, none of the dice even have a 16, let alone a multiple of 16. So you need a bit of help from both of your dice. And if we're trying to quantify how much help we need, we realize that 16 is 2 to the power of 4. So we need to make sure that our two dice collectively have cobbled together at least 4 2s. So at least 4 2s. How do we get that? Well, first of all, we cannot use the odd numbers because if I took an odd number, the other one would need 16 and 12 is less than 16. So we will need both of them to be even. And I can just note down how many 2s there are. Right, so this has 2, this has 2 squared, this has 2, this has 2 cubed, this has 2, this has 2 squared. So which means that in my 2 to the 1 group, I have got 2, 6 and 10. In my 2 squared group, I have got 4 and 12. And my 2 cubed group only has a solitary 8 inside. So to find probability, I can just look at a few cases. Now, there is a 3 out of 12 chance, a 1/4 chance that I have started off with one of these 3. And for the other one, it would need to be the 2 cubed, so only 1 out of 12. For the middle one, I would need either the 2 squared again or a 2 cubed. So now I have 3 out of 12. For the last one, if I am fortunate enough to get this, I can just take any of them in the next try. So that will be 6 over 12. So my sum will be 3 plus 6 plus 6 over 12. 12 squared, I should say, which is 15 over 144, and that is 5 over 48. So that would be option B. Now, secretly, I'm always a little concerned as I'm going through these that I have messed up somewhere because these are my questions. So I'm just taking a peek at my answers from time to time to make sure that whatever I'm doing here is the same as whatever I did when I set the question. So far, so good. Question 9. From a list of 5 real numbers, let M, X, Y, Z be the minimum, maximum, mean, median, and unique mode. Which of the following is not possible? Now, I want to say at this juncture that I am trying to set questions in the AMC style. And the AMC is a multiple choice contest. So that means that these are the sort of questions that they can exploit the multiple choice format to kind of almost give you 5 small challenges instead of 1 problem. And 5 small challenges like this can be a bit time consuming. Now, another thing that the AMC paper tends to do is to give a lot of letters that sometimes don't make a lot of sense. So XYZ here have no reason for being called XYZ, we just have to not get too mixed up. Now take note of unique mode. That means that when you have a list of numbers, you could have multiple modes. Like let's say 1, 1, 2, 2, 3, then 1 and 2 would both be the mode. So 1, 1, 2, 2, 2 would be okay because then 2 would be the unique mode. Now with that in mind, let's look at these cases and let me just try a few obvious possibilities and see if it just lands in one of these. Now, if they're all the same, my 5 numbers are just 1, 1, 1, 1, and 1, then everything here would be 1. And that's option A. So option A is actually fine if I just use 5 copies of 1. Now, let's look at the other possibilities and do something just a bit random. Like let's say if I've got 1, 1, 1, 2, 3. Now, that means that this is 3. The mean is the sum, which is 8 over 5, 1.6. The median is the one in the middle, and the mode is this. So here I get M equals to Y equals to Z less than X less than big M. And okay, that is actually down here. So why I'm doing this is that I just want to get a sense of what's going on, right? So along the way, I get to eliminate options and also I get some intuition. So now I think I can focus on the options a bit more carefully. Now option B says m equals to z, so the mode is the minimum value. But the mean is slightly bigger and the median is slightly bigger. So the median is bigger means that the mode can only appear twice. Let's say this. The median is bigger and the mean is slightly smaller than the median. So that means that maybe I did something like 1, 1, 5, 6, 7. Does that work? Maybe I'll just do 1, 1, 15, 16, 17. Right? I want to make sure that the mean is only going to have 3 big numbers and 2 small numbers. So if we did this, you're going to have your boundary values. Mean is going to be 10, median is 15, and the mode is 1. So that does actually work out. Okay, let's try option C. X, Y, Z are all the same, which means they are in between the minimum and maximum. Well, I could just do 1, 2, 2, 2, 3. Okay, let me just write that in from earlier. So 1, 2, 2, 2, 3 will work here. That already means that this is wrong. At this point, honestly, I would just take this answer and move on. But if let's say we were checking, I'm not going to do any checking here. So if you were checking, you should definitely try to also find what the possible argument is for this being impossible. So this one says m equals to y. So the median is the minimum. Now that means that the minimum has to appear 3 times. M, M, M. But if it appeared 3 times, that would also be the mode. Right? The mode would also have been m. So it shouldn't be less than the mode. It should be equal to the mode. And so that's the reason why we know option E is not possible. Okay. Question 10. Andrea, Bryson, and Carlos undergo a 45-minute interval training workout. They respectively start on 3 treadmills set at 5.5 miles per hour, 8.5 miles per hour, and 10 miles per hour. Whenever the person running on the 10 miles per hour treadmill gets tired, they move to the 5.5 miles per hour treadmill, who moves to the 8.5 one, who moves to the 10 one. So they rotate. This rotation happens 22 times during the workout. At the end, Andrea, Bryson, and Carlos have covered distances in the ratio 6 to 10 to 11. What is the total distance in miles covered by Andrea? Does this sound like it's going to be a lot of algebra? Well, 2 things tell me that it's not going to be a lot of algebra. 1, this is question 10. It should not be that bad. 2, how on earth am I supposed to deal with 22 rotations? How many variables do I even want to come up with? So whenever you have a question like this, you need to sit back and try to see if there's anything that is interesting about this. Right, now we start, let's say, at Andrea, Bryson, and Carlos. A, B, and C are here. And then in the next rotation, Carlos comes here, Andrea goes here, and Bryson comes here. On the next rotation, Bryson comes here, Carlos comes here, and Andrea goes there. So we see A, B, C appear in all of these. But that isn't very useful because we don't really know whether the time intervals are the same or not. In fact, it can't be the same, otherwise then the distances wouldn't be in such a ratio, they would be all around equal. So it means that Andrea probably spent a lot of time on the 5.5 one, Bryson spent more time on the 8.5 one, Carlos spent more time on the 10 one, something like that. But the key observation here is that all the treadmills are always running throughout. Right? So if they're always running throughout, the total speed of all 3 of them is just the sum, which is 24 miles per hour. And so that means that I can ignore all of this nonsense and say that the total distance for 45 minutes, 3/4 of an hour, would be 18 miles. And so if the total distance is 18 miles, then Andrea's ratio is just 6 out of this total times 18, which is 4 miles. And that's it. And I can see that we have at least beat the 30-minute target, and I think subtracting off the explanation, we have also beaten the 25-minute target. So that's a good pace for the first 10. In recent AMCs, there have been these sorts of questions a few times. I think memorably there was the cone question from some years ago, where you drop a marble into a cone and, spoiler alert, the actual size of the marble does not really matter. So there will be questions like this with redundancies, right? The redundancy here is the 22 times, and there are also redundancies over like exactly how they rotated. When a question looks like it's a bit too hard, this is what you should be looking for, right? And don't be afraid to skip a question, even though it's at question 10, and come back to it a bit later. Alright, question 11. In the adjacent figure, triangle ABC is a right triangle and D is the foot of the altitude from A to BC. Given that AD is 7 and BC is 17, what is AB plus AC? Now that's a little annoying. It's a little annoying because we don't get Pythagoras. Well, at least we don't have two sides in any of our three right-angled triangles that allows us to use Pythagoras. But that does not mean that you cannot use Pythagoras. It just means that we'll have to accept an x and y in our Pythagoras equation, which is x squared plus y squared equals to 17 squared, which is 289. So we have to accept that. The follow-up question is, what exactly do we want? We want x plus y. We've got x squared plus y squared. We want x plus y that is not quite as we would like. Well, the good news is that x plus y squared contains the x squared plus y squared, and also it contains xy. Now, xy does mean something as well. It means, well, xy is 2 times of the area, right? Half times x times y would be the area, so x times y is 2 times of the area. And we have 7 and 17, which is also the area. So the area equals to half times 7 times 17 is equals to half xy. So xy is equal to 7 times 17, which is 119. Now with that, we are basically done. We just put it in, 289 plus 119, which is equal to 408. Do I have that right? I hope so. Oh no, I do not have it right. I forgot to multiply by 2. Excuse me. That would have been very embarrassing because it was none of my options. So 2 times 119, and this is equal to 527. So 527, and you square root it to get square root of 527. That's equal to 17 times 31, so you cannot simplify it any further. Question 12. Let xy be real numbers such that x cubed plus y cubed equals x plus y cubed, but x squared plus y squared is not x plus y squared. Determine the minimum possible value of x squared plus y minus 20 squared. Now, x cubed plus y cubed equals x plus y cubed. It's not normally true, right? Normally, x plus y cubed gives you some stuff. Now, x plus y squared is also not normally equal to x squared plus y squared. So that's not so surprising. But this one, we need to look at it and find out when it is true. And let's expand it on the right hand side using, well, the binomial theorem or just a simple cube sum identity. I know I can cancel off these. I can cancel off the 3 for good measure. So I have got 0 equals to x squared y plus xy squared, which can be factored as xy x plus y. Alright, so that means that I have got 3 things multiplied together, which could be 0. Either x is 0, y is 0, or x plus y is 0. Well, it would be nice if I could let x be 0 and y be 20, right? That would give me the minimum of 0. But I can see from the corner of my eye that does not satisfy x squared plus y squared is equal to x plus y squared. That does not work out. Rather, it does work out that they are equal, which is the problem. Now, x plus y squared is x squared plus 2xy plus y squared. So if these are not the same, it just means that xy is not 0. And so the conclusion is that x plus y is 0 and x is equal to negative y. Okay, so now that I've got that down, all I need to do in finding this minimum possible value is just substitute in x is minus y, or rather x squared is equal to y squared, and expand this and complete the square. So I'm going to expand this very quickly, complete the square very quickly, and tell you very quickly that the answer is 200. When y is 10 and x is negative 10. Question 13. Positive integer n is said to be self-counting if for any digit d which appears in n. Ooh, spelling error. Okay, I will change this in the one in the description. For any digit d which appears in n, d appears exactly d times. How many 7-digit self-counting numbers are there? So it means that if there is a 1, 1 has to appear 1 time. If there's a 0, well, in 0 appearing 0 times. So 0 cannot appear. If 0 appears, it has to appear 0 times, means it does not appear. So there's no 0. 1 will appear once, 2 will appear 2 times, 3 will appear 3 times, and I guess that also means I cannot have 8 or 9 inside, because 8 cannot appear 8 times in a 7-digit number. So it means that I need to come out with a combination of 7 digits, which includes either 1 1, 2 2s, 3 3s, 4 4s, or something like that. So I can tell that there are not going to be too many, because let's say that if I only have one different digit, that must be 7 sevens. If I want to have, I'm just going to call it 7, right? I think we all know because it's self-counting, so 7 is counting itself, 7 sevens. If I have 2 of them, I can have 1 and 6, so 1 1 and 6 6s, 2 5, or 3 4. And if I would like to have 3 numbers, I can have 1 2 3 is already 6, so I can only do 1 2 4, and that's actually all. Okay, so now I just have to count how many numbers there are, because I could still arrange my digits. So 7 sevens is just, well, one way. 1 1 and 6 6s, I just need to choose where to put the 1. That would be 7 choose 1. Choose where to put the 2, so 7 choose 2. Choose where to put the 3s, that's 7 choose 3. And for the last one, I've got 1 1, 2 2s, and 4 4s. So I can choose where to put the 1. And then I have 6 more positions to put the 2s. And so this is all, and I have to add them. So 1 plus 7 choose 1 is 7. 7 choose 2 is 21. 7 choose 3 is 35. 6 choose 2 is 50. So if we got all of this right, we get 1 plus 7 plus 21 plus 35 plus 105 is exactly equal to 169. 13 squared, although for no reason in particular that I can discern. I think it's just a coincidence. 14. 2 political parties contest an election with 5 seats at stake. For American friends, there are definitely political parties contesting an election with more than 5 seats at stake very soon. Now, I'm sure that the parties are not going to assign them randomly, although to be fair, the popularity rating kind of makes sense. And so, for this question, we are saying that for your 5 seats, you assign them randomly, and if you have a higher popularity, you definitely win. If you have equal popularity rating, then it is a 50-50 chance. So what's the probability that one party wins all 5 seats? So I guess you might want to try to make that one party have all the higher popularity ratings, but wait a second, they have the same set of popularity ratings, right? So I can't really make one of the parties be more popular. Sounds appropriate, doesn't it? You can't make a party more popular, but you could push the popular candidates to different places. But it does come at a cost. Because if, let's say, you try to make, in a seat, 5 is more than 4, so you win. Now let's say you try to do this again, 3 is more than 2, 2 is more than 1, and then you're left with your very unpopular candidate, which is bound to lose. So you will not win all 5 seats. So rather counterintuitively, this means that the moment you win somewhere, you have a deficit, so you're going to lose somewhere else. The total is still 1, 2, 3, 4, and 5, which is 15. So you're going to always lose somewhere if you have won somewhere by higher rating. The only way is that you have equal rating everywhere, and it just happens that you got the 50% on your side every single time. So the only way is that your 1, 2, 3, 4, 5 are aligned, and the same party wins every single time. 5 wins of the 50-50 distribution. Okay, so there are two different things here because there is randomly assigned and then there's the 50% chance. For the randomly assigned, there would only be, well, we can think of it as one party rolls the dice first and then puts 1, 2, 3, 4, 5. The next party, there's only a 1 in 5 factorial chance that you landed up in the same ordering. So same ratings. This is the chance. Now, one party wins everything. So you have a sweep. Well, it could be either party, right? What's the probability that one party wins all 5 seats, not the first party? So one party wins all 5 seats, not one particular party. It could be half to the power of 5 in either direction, which is 1 over 16. So therefore, your answer is 1 over 1920, which is, I guess, a victory for democracy, that you do not have a high chance of a sweep if all the parties actually have the same popularity ratings. Question 15. Let the coordinates of point P equals x, y, z satisfy x squared equals to 2y plus 3, y squared equals to 2z plus 4, and z squared equals to 2x plus 5. What's the area of a circle centered at 1, 1, 1 passing through P? Can we solve for P? Is the question that I have. And the answer would be probably not. We could in theory, but in practice this would be too horrible because each substitution is going to get worse and worse and worse, and we don't really like that. Now the question is also fairly peculiar. It asks you for the area of a circle centered at 1, 1, 1. Now we have actually 3D coordinates, and yet we are asked for area of a circle. So in order to be able to answer this question, it means that the radius must somehow be fixed. And the radius must be fixed means that the distance is fixed. And the distance, I know the distance formula. So the radius is equal to the distance between P and 1, 1, 1. And this will be equal to, in 3D, you have got these. And if we were to expand all of them, you get x squared minus 2x, y squared minus 2y, z squared minus 2z, and I'll just group the 3 ones at the back like this. Does it look familiar? It should. It should look familiar because if you just shifted these over, you get x squared minus 2y, y squared minus 2z, and z squared minus 2x. If I added them, then I would get, I'm a bit lazy, and also for the AMC you shouldn't do extra writing, so I'm going to just say box is equal to 12, right? And so if box is equal to 12, then my sum is going to be 12 plus 3, which is equal to 15, and if it is equal to 15, that means that the area is pi r squared is 15 pi. So the answer to question 15 is 15 pi. Question 16. After simplifying the continued fraction, 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over dot 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 into a single fraction in lowest terms, and this continued fraction contains 22 ones. What is the remainder when the numerator is divided by 7? Okay, so what you definitely need to do here is to find some sort of a pattern. And I guess we can start like this, right? So you've got 1 over 1. Then after that, if I had these three, it will be 1 over 2. Now, I think, therefore, it isn't really going to make much sense to just have a 1 over nothing, right? I should do it like this. So this is 1 over 2. Now, this is 1 over 1 plus 1 over 1 plus 1 over 1 is 1 over 2. Okay, I'm going to just use an eraser and overwrite. So this is 3 halves, and 1 over 3 halves is 2/3. So that is what we get next, 2/3. Now, we don't really want to calculate this again, but we do realize that we can kind of think of the continued fraction as being stacked on top of the previous thing, right? So for example, the next one is just going to be 1 over 1 plus some blob, where that blob has 6 ones, and that blob with 6 ones is 2/3. So therefore, the next one is going to be 1 over 5/3, which is 3/5. And then the next thing is going to be 1 over 1 plus the new blob, which is 3/5, and 1 over 8/5 is 5 over 8. That looks familiar, doesn't it? It is none other than our Fibonacci sequence, which kind of makes sense if we think about it, right? 1 over 1 plus a over b is 1 over a plus b over b, which is equal to b over a plus b. So it means that it makes sense, right? You had ab, now you have b, a plus b. And so therefore, since I'm asked for numerators, I can just look at the top, which is just the Fibonacci sequence, but I don't want the 22nd term. I want the 1011 term, because all of my continued fractions, I used up 2 ones in going to the next one. So I should have 1011 terms of this, and I'm just going to write it down mod 7. So 1, 1, 2, 3, 5, 1, 6, 0. So I'm just adding mod 6. Sorry, adding mod 7. Shouldn't speak wrongly and confuse everyone. 4, 2, 6, 1, 0. And I just ran out of space at the correct time. 1, 2, 3. Okay. So here, if I count correctly, there are 5, 10, 13, 14, 15, 16. Let me check that again. There are 16 terms in here. And so all I need to do is to take 1011 divided by 16. If I take 1011 divided by 16, I should be getting a remainder of 3. And so it would be the third term, which is 2. And that means my answer is option A. Question 17. Which of the following is the largest? Which of the following is the largest? Now, in many cases for the AMCs and for many competitions, when you see a sequence of things where they ask you which is the largest or the smallest, you would tend to have the intuition that it should be the first one or the last one. Spoiler alert, that's not true here. If you have the indirect intuition that I would like to have the base to be as big as possible or the exponent to be as big as possible, then that's actually not quite correct. So what do we do here? Now, the first thing that we can say is that technically I can take away all of the zeros, right? If I had the 100th root, then so be it. It doesn't really matter that much. Right, so I can still compare them, the answer will not change. So I'm just going to make it look a bit simpler. Now, the next thing that I want to do is to then say that this can be expanded using the binomial theorem, but I don't really want to expand all of them using the binomial theorem. I don't want to expand all of them because the later ones are going to be puny, right? They're going to be really tiny. If I took the, right, so this is 1 plus 0.00001 to the power of 6. Now, do I really care about 0.00001 to the power of 6? I don't really think so. I mean, that doesn't do anything. Right? So I can focus on the earlier terms when I am expanding with the binomial theorem. So I'm going to shortcut it by just saying that if I take 1 plus something tiny to the n, this is going to be approximately 1 plus nx, and I'll stop there. Right? So 1 plus nx, we know that there are other stuff, but this nx is going to be the next most important term. If we look at it for our options, it means that if you multiply 6 in, this becomes 6. You multiply in, it becomes 10, 12, 12, and 10. So immediately you get to eliminate options A, B, and E. They are smaller than C or D because the terms behind are even tinier. They're not going to help. They're going to have just too many decimal places. So we are left to compare these two over here. And now, in order to compare them, I am going to add the next term, which is n choose 2 times x squared. Right? This is the next term in your binomial expansion. And let's see. Option C is going to be 4 choose 2 times 0.00003 squared, and this would be 3 choose 2 times 0.00004 squared. Now I am not going to deal with all those zeros. There are the same number of, oh, I forgot. Now there are the same number of zeros, and there are the same number of zeros in both of them. So I can just ignore them and just treat it as 4 choose 2 times 3 squared. 4 choose 2 is 6, and 3 choose 2 is 3. So this is 54 versus 48, and therefore option C is bigger. Not by much, mind you, but they are very small anyway, so I guess all things are relative here. Question 18. Now, this is the point where I think the amount of space I've left is not going to be enough, so I'm going to just give myself more space than I've given you. Anyway, it is going to be an online paper, right? So the space we have here is meaningless. You can't draw on the laptop anyway. Question 18 is asking you to find the value of k in this equation. Well, k is just the number of decimal places, right? The only place where k appears is here. So it's not asking you for dk, it's not asking you for the last decimal place, it's just asking you how many decimal places are there. So we need the number of decimal places in this fraction. The number of decimal places in this fraction would be, well, it's not that obvious, right? Is it tempting to say it's 222 because of the 0.2 to the 222, but not necessarily so, right? Because you also have a 20 down there, but you're also dividing, so this is all a little bit confusing. Now, how we will go about this is to understand what does it mean when we say the number of decimal places in a decimal in base 10. Now, the number of decimal places is actually the smallest power of 10, which, if we multiply by it, gives an integer. Right? So the decimal places is just how many times you need to shift the decimal place, which is just how many times you need to multiply by 10, which is just the smallest power of 10 needed to shift it along. So that means what? That means that moving it along is the power of 10. Power of 10, I need to know, well, how does this fraction actually look like? Like, what's in the denominator when I write it as a nicer fraction? Okay, so let's just rewrite it as 0.2 is 1/5. And I'm going to prime factorize these. There's not much to prime factorize. It's just 20 and 202. So at least I'll be able to simplify my fraction fully once I get there. All right. Now what do I want to do here? I want to write the 1/5 as 5 to the negative 1. So I get 5 to the negative 222. 2 squared to the 22 is 2 to the 44. 5 to the 22, another 2 squared, a 101 squared, and I guess I'll put it here, 2 to the negative 2022. So let's combine this stuff together. The 2's combine to give you 46 minus 2022. 2022 minus 46 is 1976. So negative 1976, 5 to the power of negative 200, and a fairly useless 101 squared. So what do we need in order to make this an integer? We need to get rid of all of these negative powers, and each of your tens is going to give you 1, 2, and 1, 5. So we are in deficit of 1,976 2's, and that's of course bigger than 200. So your answer is option C. To multiply in 10 to the power of that would cancel all the negative powers and give you some integer. Okay, next up, question 19. You're given a triangle with smaller triangles, and the smaller triangles have area 1, 3, 5, 7, 9, 11, and 13. You're asked to find the area of some other triangle, RAY, which is shown as with the couple of extra dotted lines over there. So, how do we go about this? Now, the key thing is that we definitely don't have enough information to easily calculate any of the lengths in here. Can we assume it's a right-angled triangle to cheat a bit? I don't think you can. I don't think it would help that much anyway. Right? Similarly, assuming anything is isosceles or anything else, it's not going to help a lot. We don't necessarily have similar triangles. Some things look suspiciously parallel to each other, but it is not drawn to scale. At least I know I didn't draw it to scale, so it's a bit hard to tell whether those are actually parallel or not, just from the diagram. So maybe let's just think about it. If let's say that I didn't know any lengths, what would I actually want in order to get this area over here? Now, something that would make sense to me would be to try to subtract off those other two leftover triangles from the total. Right? Because the total is just 49. And so I could subtract off those, and the reason why those are better than my green triangle is that they share an angle with the full triangle. And if they share an angle with the full triangle, it means I can use ratios to help me, since they have the same base or the same height or at least something like that. Okay, so first of all, I can see RYZ actually shares one side with the original triangle. So that would be easy to find as long as I knew this ratio over here. And I can find that ratio. XR to RZ could be found, I'll erase everything for now, could be found by comparing this triangle to this triangle. Right? They have the same height, so the ratio of areas will be the ratio of the bases, which is 25:11. So straight away, if that's 25:11, if I were to look at this portion over here, XRZ is equal to 11 over 36, right? 11 over 36 of the whole thing. And I guess I can just get XRY as 25 over 36 first. Okay, so that's the first thing. Now, in order to carry on, to get xry to ray, I actually just need the ratio of this to this. The question is, can I get that? And the answer to that question is, well, it's not that obvious. So we'll still need to get the ratio in some other way. And in order to get the ratio, I realized that, well, in the first place, I just wanted to subtract off XAR. So I don't need to compare it to the whole thing. It is enough if I just compare it to something else. And I think comparing it to the one nearest to it is a bit easier, because I can do this. So it means that XA to AB is 4:5. And so XAR, I can compare it not to the whole thing. Whoops. I can compare XAR to just XBR. So it's equal to 4/9 times 16, which is 64/9. So my final answer, I would take this minus this. Little bit of calculation to do here. I hope I haven't messed anything up. Let me just multiply again and check. So this would be 969. Oops, I forgot to change this to 36. Okay, I'm seeing that this is one of my options, so that is good. 323/12. Right. Question 20. Which of the following is equal to this bunch of square roots? Now, if you're looking at the time, by the way, right, you see that I am crossing the hour mark as I am getting to here. It's not really the hour mark, it is 50 plus minutes. So if you feel that I'm going very quickly, and I am the person who set the questions, so I don't really have to, be completely lost over any of this. Now you understand the difficulty involved in taking the AMC, right? We are at question 20, and as it is already an hour. To finish it, you need to go even faster than this. So faster than the rate that I'm explaining it. And so again, accuracy at the first few questions is important. You can see difficulty is sliding up very steeply. So which of the following is equal to this thing here? We can kind of see that there is a lot of symmetry in our computations. Now, normally in these cases, if they were truly conjugates of each other, I would like to square the whole thing. Right? I'm not going to show you why, because they aren't conjugates here, at least not the entire thing. Right? You have got two different sign flips, so that's not so nice. So I would like to deal with the individual square roots first. I hope I'll be able to simplify them. And most of the time, it is useful to simplify the inner square root first. So you get 3 plus 2 square root 2. Now, if using a little bit of wishful thinking, we were to hope that this can be simplified into something like a plus b square root 2, that means that 2 must be the 2ab square root 2 when you square it. So let me explain that. 3 plus 2 square root 2 should be equal to this square, which is a squared plus 2ab square root 2 plus 2b squared. Now, if we are trying to get this such that a and b are nice, this is wishful thinking, you would need 2ab to equals to 2, and of course, if ab is equal to 1, we try 1 and 1, and magically it works. So this is good news. So it works, and so therefore this is just 1 plus square root 2. Now here's a little trick when you're dealing with these sorts of conjugates. You see that for this one, 3 minus square root 8, and you want the square root of that. Since all that has happened is the b has flipped, I mean the minus has flipped here, the b is the one that has to flip, or the a can flip. So what I mean by that is that your a squared plus 2b squared would still be 3. We are trying to now make 2ab into negative 2. So we just flip one of the signs. 1 minus root 2 or root 2 minus 1, keep the positive one. So square root 2 is certainly more than 1, so the positive thing is square root 2 minus 1. Now that we have this, we can simplify our expression into 1 plus square root 2 minus 2 square rooted plus square root 2 minus 1 plus 2 square rooted, and this is equal to the square root of square root 2 minus 1 plus the square root of square root 2 plus 1, and this now does include conjugates. And all of my expressions here, my options rather, all of them are the square root of something. All my options are the square root of something. Now, not 2 square roots, but the square root of something. So it makes sense that I should just square this thing and find out what it looks like. So I shall square this thing. The first term squared gives you this. The second term squared gives you this. And the cross term gives you 2 times the square root of this. Okay, now this is why I was trying to hint at earlier. We like conjugates because, well, these are not true conjugates, right? It is negative of a conjugate. Never mind. Conjugates are when you flip the sign on the square root. This one is kind of almost a flip, but it's good enough because something will cancel out here when you add them, and also something will cancel out here by difference of squares. You get square root 2 squared, which is 2, minus 1 squared, which is 1, and square root of 1 is 1. So the expression squared is 2 square root 2 plus 2, and thankfully that's one of our options. The answer is E. Question 21. Two mathematicians, Hardy and Littlewood, are having lunch together. Hardy writes 3 distinct non-zero real numbers PQR on a napkin. Handing the napkin to Littlewood, he asks, "These are the coefficients of quadratic expression I'm thinking of. Can you figure out any of its roots?" Littlewood responds, "Of course not." Hardy then says, "If I told you the term which has P as its coefficient, you would know one of its roots." And Littlewood responds, "That's okay, I already know what that root is." What is the value of that root? So as we can see in this question, there are no numbers given except for the options at the end. No numbers whatsoever. And so I guess none of us are going to be too shocked by "of course not." Sure, if I just told you I'm thinking of 1, 5, and 7, what are the roots of the quadratic equation which has coefficients 1, 5, and 7? You will say, of course I don't know, because there are so many different orderings that it could be in. So if there's so many different orderings, how am I supposed to know which one it is? Because different orderings would give you different roots, right? For example, if let's say I gave you one, so let's use something which I know actually gives something concrete. Maybe I shouldn't, because I may leak out the answer too early. So I'm sure you are convinced that different orderings would give you different possible outcomes. And they're distinct as well. They're non-zero, so you don't have some case of, oh, actually it was just 2, 2, and 2 or something like that. We don't have that. So the of course not doesn't appear to be saying a lot. Now the second statement, Hardy says, if I told you the term which has p as its coefficient, you would know one of its roots. Right? So that means that if Hardy were to tell Littlewood one of the coefficients, right? P is, we're not sure what number that is, but if Hardy placed it in, then he says that Littlewood would now know one of its roots. And Littlewood responds that he already knows it just from Hardy's statement. Okay, so let's try to figure out what's going on here. Now it means that Hardy is saying, if I told you which term has p as its coefficient. Now we're not sure what would Hardy have said because we don't know, p is literally just a variable for us. But if let's say that he was referring to the first term, it means that Hardy in his mind was thinking, well, if I told you that the coefficient of x squared is p, then regardless of which of these was the actual thing, we would already know one of the roots. So it means that these two have a common root. So if they have a common root, then it means that there is some value of x that makes both of these 0. But what I can do is to subtract them, because it means that my root will also be a root of the difference. Right, so the px squared will cancel out. This is qx minus rx plus r minus q, and this can be factorized. It is q minus r x minus 1. So my common root would have been also a root of this. So that means that x is 1, right? Wait a second. Well, if let's say x is 1, so in this case it would mean x is 1. But if x were 1 is the root, that means that p plus q plus r is 0, right? And if that were the case, it means that actually the order of all three of them doesn't matter. If x is 1, it doesn't actually matter where p, q, r were at. Littlewood would already have known in the first place. Would have immediately been known. So it means that x is actually not 1. And we will need to look at another case. And let's say we compare these two instead. So if let's say that Hardy had told Littlewood that p is the x coefficient. Now, by the same reasoning, if I subtract them, I get q minus r x squared minus 1 equals to 0 at my root. And this can be factorized as well. But I see that here now there are two possibilities, which is x equals to 1 or minus 1. I ruled out 1, but minus 1 would have been already possibly the solution. Now let's just check the other case, and it's going to be the same, so I'll write this very quickly. If p were actually the constant coefficient, p is the constant coefficient, what would have happened? I subtract them, now I get q minus r x squared minus x equals to 0 at the root. And this is x minus 1. So x equals to 1 or 0. We have already ruled out 1. So could it be 0? Well, if it was 0, that means that p is 0. But the question already says that they are non-zero. So that means that this also is ruled out. So now it all makes sense, right? It makes sense because Hardy basically says that if I told you, you would know. And the point is that just by this statement alone, it means that Littlewood does know. Because the fact that this would have worked means that only the second case, so Hardy's statement, if I had told you, is enough for Littlewood to realize that there's only one thing that he could have told that would have been enough, so it is enough. And so therefore the root is -1. Confusing? Absolutely. So this is one of the things that you can discuss in the comments below if you are a little bit confused. But mainly this just needs a few minutes of just processing, and if you are new to these sorts of questions, they are really fun, but also really strange at first. 22. On the Almost Math Counts contest, students receive an integer score between 0 and 46 inclusive. The students in the Math Olympiad class obtain an average of 35.79 after rounding to 2 decimal places. What is the minimum possible number of students in the class? Now that means that the actual average after rounding to decimal places is this. So the range would have been 35.785 to 35.795, excluding the second endpoint. Right? This is the actual range. And let's say that there are n students and the total score is m. That just means that the average is m over n, and the average m over n just lies somewhere in here. Right? So this is literally what the question statement is saying. Now, I want the minimum possible number of students in the class. Now, it is not very difficult to have an average of 35. I could have one student getting 35. The difficulty is the decimal place. Right? If let's say I only had 2 students, I could only have either an average of an integer or something 0.5. I could not have an average like this. If let's say that I had 3 students, the average could only be either an integer, 0.33 or 0.67, and I could not have an average like this. So in a way, what happens here is just that we need to look at these denominators potentially and just see which one of them will work. Right, now this is an AMC, so you can exploit the options on some questions, and this is one of those that I said where you are supposed to exploit the options. You don't really need to solve it because it isn't actually a very nice way to solve it if you're being honest. So m over n is in this interval, means that I want something over n to be possibly like this. So I can change this to, let's say, something over n, so let's call it x over n, must be able to land in this interval. Right? The integer part's not very important. Now that means that x has to be actually part of this interval, and x is arbitrary, so I just need some integer to be in this range between 0.785 and 0.795 n. Well, so no choice, right? We need to check. But what we hope when we are checking is that it lands somewhere where this is just slightly under an integer, so that this one will be slightly over an integer, and if that's the case, there will be an integer in between, which could be my x, and if it could be my x, then I would have a total score. So try n equals to 11, slightly annoying, but multiplication by 11 is not so bad. Right? Just take 7.85, which is 10 times, plus 0.785, you would get 8.635. And that's not close enough, right? This is only going to be 0.11 away. The difference is 0.1 n, so 0.11 away. Now we just try the next one first. N is 14, and that means that I need to add 3 times of this to that, which is 2.355, and you get 10.99. Oh great, so this is definitely going to work. Plus 0.14 11.13. Okay, so it works because you can take x is 11 over 14. And that's good enough. Now, if some of you frequent the AOPS forums, problem solving forums, you will see people saying this is a horrible bash question. I'm sorry, but there are always horrible bash questions in the AMC, so it is needful to include at least one or two of them. This is not a horrible bash if you just use the options, right? But a horrible bash in the sense that there isn't really much mathematical value here. It's a bit boring once you have figured out what the question is trying to tell you. Having said that, this is something that I have used last time as a student. Whenever I looked at the average of a class, I always can use that to figure out how many people took part to some degree of certainty. So this is a little bit of a sneaky trick you can use to find out participation rates given the average. Okay, question 23. How many 6-digit positive integers have digits which sum to 13, 22, 31, or 40? Now, the answer is, or the answers are very suspiciously clustered around 100,000. Now, sometimes the AMC does this because they want to kind of trap you into making a careless mistake. So if you make a calculation error, you may accidentally land up in the other option. But in doing so, they have also given you a hint as to the range, and so that gives you the general strategy within the options already. Now, how many 6-digit numbers are there in the first place? Well, for 6-digit numbers, I like to say that there are 9 choices for the first one and 10 choices for the rest, which is 900,000. So these are very conspicuously about 1 in 9. Now, why would it be approximately 1 in 9? Well, I can also see that my numbers differ by 9, right? So it means that I kind of took every 9th number, and so it makes sense that it's about 1 in 9. I mean, somewhere in that ballpark is not completely illogical. But did I actually take everything, every 9? So the range of sums, 100,000 is the smallest one, so that would just be a sum of 1. Now, 99999 will be the biggest one, so that's 1 to 54. So there are 54 possibilities. Obviously, 1 and 54 are a lot less likely, and something like 2 is also not very likely, but they are there. So I did not, in the question, have 6 possibilities. I had 4 possibilities, and they're kind of like 2 missing, right? It's like 4 is missing, and then these 4 are there, and then 49 is missing. So there are like 2 numbers that seem to be missing. Now, if they weren't missing, then there's something interesting we can say. If these were not missing, if I told you that the sum of digits is this is literally every possible way to get a sum which is 4 mod 9. And 4 mod 9 just means that so the digit sum is 4 mod 9, means that the number itself is 4 mod 9. Right? Because the divisibility test for 9 tells you that the sum of digits is congruent to the number itself mod 9. They have the same remainder. And so therefore, the number itself is 4 mod 9, and if the number itself is 4 mod 9, that is 1/9 for my numbers. There are 900,000 of them, and so if I included all of these, it would have been 100,000. Right? Because every 9 numbers, there's 1 that is 4 mod 9. So 1 out of every 9 is 100,000. I just need to subtract off those that sum to 4 and those that sum to 49. So let's try to do that. So the sum of digits being 4. That feels like it can be listed out, right? And the only problem with listing out is that the first digit is not going to be 0. So there's a little bit of asymmetry which we need to deal with. Now, how I can deal with that would be something like this. I just say that, okay, I have got 6 spots, 6 digits. I give it 1 already. And now there are 3 more in my quota. I need to distribute it here. And so this becomes a classic partitions problem, or balls and boxes, or stars and bars, depending on what name you have heard for the technique. And the way that it goes is that we say that we have 3 to go into these 6 locations. It's as good as having 3 stars or 3 items and 5 partitions arranged in a row. If we arrange these in a row, this would mean 3 0 0 0 0 0. So you give 3 more to the first one and you get 400,000. If let's say that I had moved one of them over to here, then now it would be 2 0 0 1 0 0, and that will also give me a number 300,100. So the number of arrangements here is going to be 8 through 3, which is equal to 56. Now, the other case is when the sum of digits is 49. Now for this one, I can't use this same approach because I'm only allowed to give at most 9 to each one. So I cannot do something like 30 to the first one, 10 to the second one. I'm not allowed to do that. So what I would like to do instead is to start off with 9 in each spot. And now I say that I have excess of 5 because it is 54 and I want 49. Now the excess needs to be removed out of this, which is actually the same thing again. I need to remove 5. I don't have to worry about hitting 0 or negative, so that's okay. Now I, in this case, need to arrange 5 balls and 5 partitions, which is 10 choose 5, that's 252. Okay, and so therefore your final answer is 100,000 minus 56 minus 252, which this is 308, so you get 99692, which thankfully is my option B. Okay, here's a tip for those of you who are mocking AMCs, like past AMCs, right? Don't waste the questions. I know not all the questions are that great, but many of them are really fun. So don't waste the questions at the back. Do a timed practice of 75 minutes just to know how fast you are. But don't waste the questions behind. Maybe you don't want to do them immediately, that's fine. Save the questions and use it for later. Because these questions sometimes have really unusual ideas, but you don't have even time to read them in 75 minutes. So if you are one of those many participants who does not really have time to read the last 5 questions, or at least you only have time to glance at them, my suggestion, please do try these questions at some point in time. It's a huge waste to just throw them away because you really learn a lot from some of them. I hope this one's interesting. Right? I did like this problem personally, if I do say so myself. Okay. Question 24. Cone X has radius 9 and height 15. Cone Y is inscribed in cone X such that its vertex lies on the base of cone X and the bases are parallel to each other. So this smaller one's cone Y and the bigger one's cone X. You know that the radius is 9, the height is 15. What's the maximum possible volume of cone Y? First things first, volume formula. Volume formula for a cone is 1/3 pi r squared h, where r is your radius and h is your height. Now, so we know that we don't want an extremely narrow cone, like something like this is going to have a really tiny area, so we don't want that. We also don't want an extremely fat cone, because if we have a really fat cone that is like this, there's still a cone, but not much good in terms of volume. So in order to do anything about this, we need to learn a little bit more about how r and h are related to 9 and 15. Right? I mean, obviously I can't make r more than 9 and h more than 15. I also cannot make r and h 9 and 15 at the same time. If my h is 15, r is going to be 0. It will just be one needle. So how do I make sure that I have something valid? Now, the AMCs have a lot of 3D geometry questions, and if you're like me, you cannot really visualize too many things for 3D geometry at the same time. So the best way to go about it is to take a cross section that passes through something symmetric, right? Some line of symmetry. And in this case, I'm going to sort of like divide the cone in half. Right? Divide the cone in half. What I would see is a big triangle and a small triangle. Let's draw it like this. I don't really know how it should be, but I'll just draw it. Now, we're not trying to make the area of that triangle as big as possible. That's not what we're trying to do. We're just trying to figure out how r and h are related to everything else. So in my diagram here, this is r and this here is h. Now, I also know that this is 15 and this is, sorry, not this. This is 9. And so that means that my triangles here, by symmetry, I should have parallel lines, and so I have similar triangles. Now, I'm not going to actually write down the ratios. I'm going to just think of it in terms of scaling. Now, imagine if I were to take that 9 and 15 triangle. Now, this is not a 9, 12, 15 triangle. 9 and 15 are the legs. But imagine that I am just shrinking it to here. Now, if I'm just shrinking it to there by some factor, let's call it x. If I'm shrinking it by a factor x, that means that this is going to be 15x, this is going to be 9x, and this is going to be 15 times 1 minus x. And that basically already is r and h. They are bound by the fact that there is one variable, x, controlling both of them at the same time. So I can substitute r is 9x and h is 15 times 1 minus x. Okay, so lots of constants to take out. 9 squared is 81, divided by 3 is 27. 27 times 15 is 405. You see 405 in the options, don't you? So times x squared, 1 minus x. And this is now my volume. I just need to select x. Now, one way to do this is just to plug in values to try to get the options, right? And if you just try that, for example, if we try x is 0 and 1, that's a terrible idea. If x is half, we will get 4 or 5 over 8. If we try x is 1/4, we try x is 3/4, 2/3, 1/3, 1/5, whatever, 0.3, 0.4, and just try to get an estimate of what's going on. If we're really desperate, we can most certainly do that. But for this question, and this specific thing, to maximize it, we can use the AMGM inequality. And I'm just going to take the x squared 1 minus x. Now, the AMGM inequality is saying that the sum and the product can be compared. And the product side is going to be smaller in some sense. Right? So specifically, the AMGM inequality, we know that it's saying something like, if we have, let's just use 3 variables as our example. The arithmetic mean, the usual average, is greater than or equals to the geometric mean, which is the product and then take the root. So if I want to get a maximum on a product, I can use the other direction as long as the things that I were multiplying sums to a meaningful total. Now, I don't want to say that this is therefore less than or equals to x squared plus 1 minus x over 2. It is true, but pretty useless. Now, what I would like to do is not to have any x squared. I need to cancel off the x, so I am going to go with x times 1 minus x. But that is still not good enough because x squared was not able to cancel it off here. You have cancelled it off too much. So here's what I'm going to do. I'm just going to make it cancel out by just taking an extra factor of 2. Right, I can do that. So x squared, 2x squared 1 minus x is equal to this. And now this thing is less than or equal to this cubed. Right, so the cube of the geometric mean is less than or equals to the cube of the arithmetic mean, and this is 8 over 27. Okay, so what have I said here? I've said that 2x squared times 1 minus x is less than or equal to this, and for the AMGM inequality, equality holds when all of the stuff you put in are the same. So x and 2 minus 2x are the same, means that 3x is 2x is 2/3, which is perfectly reasonable, right? 2/3 times 2/3 times 1/3 times 2 is indeed 8 over 27. Right, so all we're left to do is to substitute it back in. Now take note that it is 2 times of it is less than or equals to this, so your answer is this times 4 over 27. Sorry, I forgot the pi almost. This is equal to 60 pi. X equals to 2/3 is maybe possible to guess, since you definitely would prefer 2/3 to 1/3. Right? You would like to have the square portion to be bigger than the not square portion. So that's one way to think about it. Okay, so 60 pi is the answer, and with that we are on to the last question, which is actually really difficult. And this video is therefore going to be stretching a bit longer than expected because I think this last question merits a bit of explanation. Now, I was pretty happy when I discovered this has a unique answer because there is so little that needs to be said. In a right-angled triangle with positive integer side lengths, 2 of the sides sum to 20, 22. What is the length of the third side? And that is all. Now, first of all, I was relieved that there are not multiple answers. But in a sense, I'm also glad there is an answer because there will be many possible numbers you could come up with where there isn't even an answer. Now we know that the only condition for a right-angled triangle is Pythagoras' theorem. That's the only thing that you need. So a squared plus b squared equals to c squared is basically the only thing that we need to be concerned about. But we don't actually know which one sum to 2022. Well, there's two cases, right? Leg and leg, or leg and hypotenuse. So let's try first leg and hypotenuse. Because if the leg and hypotenuse, then something nice happens. Now, we remember that we can actually move this over and factorize. So I can at least use this 2022 immediately. That's the good news. We also know that 2022 is 2 times 3 times 337, and that is the bad news. That's the bad news because if you want this to be a square, you need to make sure that your right hand side, every single prime factor appears an even number of times. And so the 2, 3 and 337 all need to appear here, which means this needs to be at least 2022, and that doesn't work because c minus a cannot be the same as c plus a. Unless a is 0, and that's not a triangle, and that's not a positive integer side length. So unfortunately, this does not work. But fortunately, it did not work very fast. So we can now get on to the a plus b. Now, this one's a little bit more tricky. It's a bit more tricky because it isn't so obvious what to do, right? If you were to try something like a plus b squared minus 2ab equals to c squared, that is a very entirely reasonable idea. The only problem is that if you did something like this, it's not that obvious how one would go about restricting C, A, and B, because A plus B just sum to 2022. Right? It's not very clear how we're going to do this. So we're going to do it slightly differently, right? And I'm going to just make a few obvious statements first, or obvious-ish statements, to make the computation a little bit less complicated. I don't want to deal with 2022 the whole time. So the first thing I'm going to say is that if A and B sum to 2022, I need both of them to be even. Now, if you've noticed, no Pythagorean triple has odd and odd. And the reason is that, firstly, if A and B are both odd, then A and B squared would be 1 modulo 4. And this would imply that your C squared is 2 modulo 4, and that does not work because a square number can only be 0 or 1 modulo 4. 0 if it's even and 1 if it's odd. So that's one of the factors dealt with, which is 2. The other one which I want to deal with is 3. So if A, B are not divisible by 3, same thing happens again. So I basically am just saying ditto, but this time mod 3. Squares can only be 0 or 1 mod 3, so that does not work. Now, conclusion is that A and B are multiples of 6. And if A and B are multiples of 6, then C would also have to be a multiple of 6. So I can scale them all down and make the computation a little bit less bad. So I'll factor out 6 from everything, and now I have just got x plus y is 337, and x squared plus y squared equals to z squared. So very quickly I bring down the number so that it's a little bit more feasible. Okay, so same issue here. The question is, how am I going to do this? And the answer to this is that I'm going to make use of a slightly more complicated result. I'm going to use the result on Pythagorean triples, primitive Pythagorean triples. Now, this is the general form of any 3 numbers that satisfy this if they are relatively prime. They have no common factor other than 1. Now, since 337 is prime, this means that my x and y will not have a common factor. If they did, then it should also be a factor of 337. So since that does not happen, the only way that this can work is that they are co-prime, and these primitive Pythagorean triples come in, where we would say that x, y, and z take on this form: m squared minus n squared, 2mn, and m squared plus n squared, where m and n are integers which are co-prime. Okay, this covers all primitive Pythagorean triples. For example, 3, 4, 5 is m equals to 2, n equals to 1. 5, 12, 13 is m equals to 3, n equals to 2. So this covers everything, right? This is not just for our example, and it's not just that, oh, sometimes it happens to be like this. No, it's all of them are like this. It can be proven. The video is long enough, so let's not prove it. So what do I want to do here? What I want to do is to just say that it means I can write m squared minus n squared plus 2mn, which is x and y, is equal to 337. And I would like to write it in this way as m plus n squared minus 2n squared. So kind of a quasi completing the square. So I'm left to figure out how exactly would this work. But since the question is already hinting to you that there's only one way, you are within your rights to just give it a try. Now, one thing that we can say is that your m and n are not going to be very big. They're not going to be very big because, look, 2mn is y. Y is less than 337. and you know that n is the smaller one. So if n is the smaller one, that means that mn is less than this over 2 is 168.5, and so n is the smaller one, it will be less than the square root. So n is actually less than or equal to 12, and that's why this is not actually going to take us a ridiculous amount of time. Coincidentally enough, the one that works is n equals to 12. So I am sorry if you tried 1, 2, 3, 4, 5. The one that works is n equals to 12. And if you put n equals to 12, this would very nicely give you m equals to 13. And so therefore, if these are your two lengths, then question is what's the length of the third side, right? The third side would be c, which is 6z. So I should just calculate z equals to 12 squared plus 13 squared, which is 313, and c equals to 6 times of that, which is 1878. And there we go. This is the mock AMC10 paper. So I hope you found the questions fun. I definitely enjoyed setting them. I tried to put in some ideas which I've not seen before, along with some ideas which I've seen a lot. And that's how an AMC paper is likely going to be. A mixture of very well-known questions and very unusual questions. Which is why, if you do not have time to get to the unusual questions, or if you see in the competition like, wow, this is really interesting, I have no idea how to do it. Try to work on it after the competition, especially if you're taking both the A and B contests, right? It's good practice, and also you get to see some fun stuff. Don't gravitate towards the most interesting question that you see, because that may be the hardest question. So it may be good for solving, but not during the contest, right? Remember, contest time is to try to do as many as you can, carefully and correctly, and score as much as you can. Practice time is to do the fun questions and learn as much as you can. Right? So these are two different objectives, and if you've been here up to now, thank you very much, and it means that you have seen the fun questions at the end. Right, so as usual, feel free to comment below if you have any feedback, any comments, or if you just like to speculate about cutoffs for this extremely hypothetical paper. It is, in my opinion, I would say that it is similar to last year, but everyone who sets a mock paper always tends to make it too hard. It's always too hard. So you might disagree and say, no, this is definitely way harder than last year, and you are well within your rights to say that. So thanks everyone for watching. Do look out for the AMC12 video to come out soon, and yeah, like and subscribe, I guess. So bye for now, and see you again soon.